For this question, we have a diagram where it shows the cross-section of the machine cover produced by this 3D printer and it's made out of plastic. Right, so how do we understand this diagram? Right, so let's say here we have a plastic bowl and it is put upside down. Okay, so from the top, if I cut this bowl by half and I remove this front part, okay, and then I view it from this direction, you can see that here inside the bowl is empty, right? Only left with the plastic cover of the bowl outside, right? Which is this shaded region. Okay, so this is what it means lah. So here we have given two lines. So one is the internal line, which is this line, and the equation is this, and then the external line, which is this line, and also given the equation. Right, so now we need to calculate the cost in RM of this plastic if we want to make 20 covers of this, and then for each cm cube it is 7 cents. So technically this question tells us to find the volume of this shaded region and then find out the cost. Right, so to find volume, here we have an issue, which is there's no x and y axis, right? Because we need to have a graph, but this one is just a diagram. So where should I put the x and the y axis? Right, so this question is actually similar to the second question. I'll put the link here. You can check it out if you haven't. But the way to answer is the same. Okay, so for the x-axis, we will put it at the ground, which is the dotted line here. The y-axis, I would recommend to put it in the middle of the graph, which is something like this. Okay, reason is because later on when we want to find volume, we need to rotate the diagram. So if we put it in the middle, it will be easier for us to find the volume. Right? So if you imagine we are putting here, it will be hard, right? Because it's not at the center, it's at the side. So if you want to rotate around the y-axis, right, technically this whole diagram will rotate together, right? So to avoid this kind of complex calculation, we just put the y-axis in the middle. So y-axis middle, x-axis on the ground to have simple calculations. So to find volume, we have two steps. So the first step is to choose our axis, either y or x. So here it would be obvious that we need to rotate y-axis, right? Because x-axis, if we rotate, we rotate downwards, which technically here we don't have anything. Okay, so let's use y-axis. And the second step is to identify the shapes. So let's take a step back. To find volume, let's find the area first, area of the shaded region. Okay? But you see from this area, right, it's actually in the middle of the graph. So we can use the big shape minus small shape way to help us find. Alright, so from the big shape, what we can see is we have this external line, and then we are using y-axis, right? So we can find the area under this curve first. Okay, this is my big shape. Then my small shape would be the parts that I don't want, which is this empty space, right? So here we can use the internal lines area under the curve, which is this one. And then to find the area of shaded region, we just minus these two regions, these two areas. And since these two regions are area under the curve, which we use integration formula, so this means for volume, we use integration formula as well, right? But there's a question you may be wondering, why did you only include one side? Why did you include two sides? Reason is because later on we need to rotate around the y-axis, right? So automatically this part would be included as well because we rotate around the y-axis. Okay, so we just include one side enough, don't have to include both sides. So now let's find the volume of these two regions using the integration formula. Right, so let's put up pi and we integrate in terms of the y-axis because we're rotating around the y-axis. So means inside should be x, and don't forget the square. Then we need to have the starting and ending points here. So starting point here will be 0, ending point will be this part here. Okay, so this part we can actually use the 3 cm here lah. So this one is actually 3. Okay. Then for this region, it's the same thing. It's just that for this part it's 2.8. Okay, we can also use the length given here, right? So this one is 2.8. Okay, so later on for these two integrals, inside must be y only because later on, because we are integrating in terms of y, right? So for this x square, we can change it using this equation. Okay, put x square on the left. Same goes to this equation as well. Okay, then we substitute inside. So when we substitute this 3 minus y, I put it inside the integral, but for the 20, I put it outside. Right, you can do this because this one is just a number. Same goes to this one as well. 16, I put it outside. 2.8 minus y, I put it inside. Okay, so now we can integrate. So 3, I just add a y, and this y would be power plus 1 divided by the new power, which is 2. Then put the 3 0 here, and same goes to this as well lah. 2.8, I put a y would be same as this one. Okay. Then later on, I just substitute the values lah, 3 and 0 inside, and minus these two values together. Right, so this is the 3, and this is 0. So 0, straightforward lah, everything will become 0. And for this one, I just substitute 2.8 inside, this is the working, and 0 I put inside, it will be 0. Right, so once I simplify everything here, the final answer will be 37.28 pi cm cube. So this is the total volume, but remember, we need to find the cost, right? So for this total volume, let's multiply the cost per cm cube, which is 7 cents. But 7 cents here, we usually to RM lah. Okay, so this 7 is 0.07. Right? And then we need to make 20 covers of this, so we need to multiply 20, right? So make pi into 3.142, and you'll find that your cost is 120 ringgit.